Pandas are with no doubt very cute animals, and they have very positive sentiment from people all around the world. Same happens to people working with data and machine learning, because many of those were raised on Pandas library that used to be a go-to tool to data exploration and manipulation. However, since some years, competition named Polars arose and is taking more and more interest. Looking at the PyPI stats that tell how many download events occurred for given Python package, we can see a strong positive trend for Polars. This library in the beginning of this year used to have 2.5 million of such events weekly, while recently it reached around 6 millions of those, which is a huge increase. In this video, we'll do a very simple benchmark for both Pandas and Polars and enjoy a 17-round long game to see in how many aspects Polars is better than Pandas and vice versa. Hello friends and welcome to the collab Pandas vs Polars. So the aim of this collab is to perform a benchmark and namely compare different use cases between Pandas and Polars. So we will run equivalent codes that do similar things in both libraries, and we would like to track the time to see which library performs faster. So to start with, we have imports in which we are importing some libraries, not only Pandas and Polars, but also some plotting libraries and ones that will be useful to develop the data frames used in the comparison. Secondly, there is a cell about ignore warnings, so we are ignoring irrelevant warnings for now, mostly deprecation errors, but eventually, if needed, you can comment that and deal with these warnings on your own. Third cell is about installing specific Pandas or Polars versions, because when you take a look below, the default versions of Pandas and Polars are 2.2.2 for Pandas and 1.25.2 for Polars. So if you want to test specific versions and you would like to compare Pandas with major being 1 and the rest being something, you can do pip install pandas as the commented code suggests, and install, for example, 1.5.3, and you will have this version of Pandas installed. Afterwards, you need to restart the runtime and run print Pandas and Polars versions once again, and make sure in the Pandas version you see the proper version. Alright. Next there is intro, which is like markdown description for people that will not watch this tutorial but will only see the notebook. So what is useful and I would like to call out is first of all the runtime. So as per default setup, you can see it should run in about 16 minutes. So also given the command below, you can run command or control with F9 and you can leave your computer for 16 minutes and come back to see the all code cells that are available here, that they are executed, and you can start analyzing the results. That's the first thing. Secondly, the default setup for long and short data frames that are used downstream is 10 million and 1 million records respectively. So 10 million records will be dumped into CSV and 1 million records will be dumped into JSON. The reason why this setup is as I just told you is that I am running and designed this collab to run on default setup, so with no extra memory that is required to hold bigger data frames. So what is also suggested here is that if you have Colab Pro or higher versions with bigger RAM setup, or you want to run this notebook locally and you have bigger RAM, then definitely it's possible and you can tune the params. I will discuss in a second. But for now, if you are running this notebook in a collab, you can go to this area and you can see resources. And yeah, currently you can see for RAM that I used half of them, so 6.4 out of 12.7. So this is the current usage, but definitely if you see that you have more than 12 gigabytes of RAM, you can safely increase the parameters I will cover in a second. The next thing is to set up the data frames. So as you can see here, you have two parameters that tell you how long will be the long data frame that will be dumped into CSV and short that will be dumped into JSON. And currently the setup is 10 to the power of 7, namely meaning 10 million of records, and 10 to the power of 6, meaning 1 million of records, which is for the short. Also, what this collab does is that it uses some Python magic or Jupyter IPython magic called %time, so that anytime you will run a code cell, it will give you information how long the execution time for a given code cell was. So when this is already done, we can check what is the data that is being used for the benchmarks, which is like very basic dummy data with some integer person ID, age and salary being integers, experience in months being also integer, and rating being a string. Secondly, we have short dummy data, which has a very similar schema but shorter length, and also data for joins, because we will definitely evaluate joins in this benchmark collab. So you can see person ID, that will be a key used for join, and country being either USA, Poland, or Ukraine. This is the dummy data. And also to organize the experiments nicely, I created two classes. Let me maybe close this side box so that it's better visible. And so there are two classes. We can inspect them by clicking show code. So first one is Pandas Polars benchmark. So this is a class that wraps all of the single experiments and helps us build the final plot that will show us in the bar plots like what was the execution time for a given use case in both libraries. And it has some init method, add experiment, which appends experiment to the class instance, summarize experiments that builds a pandas data frame that calculates like time of each experiment and shows you in nice tabellaric form. Plot final verdict, which will prepare the final plot we will see in the end of tutorial, and it will tell us in how many use cases pandas or polars was better than the opponent. And finally the get final result, so it will help us to build like a title in which we will directly see how many cases polars beat pandas and vice versa. And secondly, we have Pandas Polars experiment. So this is a class for a single experiment. It has times, start and end for both polars and pandas. And basically it calculates times. So this is a separate method that will calculate in seconds how many seconds were needed to execute some part of code. And also has a method for summarization of single experiment. There is also a method called plot experiment, and it basically prepares you a figure object that is a bar plot containing data just for one experiment that will show you execution time between pandas and polars. So for this notebook, we just instantiate pandas polars benchmark class and call the variable benchmark. The next step is to perform the benchmarking, and let's start from the experiment 1, and I would like to show you the code that is pretty much in terms of schema repeated across all code cells. So first of all, we have time magic, and what it does, it shows us below nice printout how long given code cell run. In this case, it was 33.6 seconds. And this is a message for you if you want to change the behavior of the benchmark, you would like to repeat experiments, you will use these timings to have some sense like how long the notebook will run, and eventually you can adjust it accordingly to run the benchmark just for one experiment in the time you want. Secondly, there is experiment, so we call Pandas Polars experiment class, we name it, pass it to the init, and we create experiment object. And there is a part of code that does one use case, so this is read JSON method from pandas and read JSON method from polars, and this is wrapped by calculating start time and end time for both libraries respectively. And finally, there is wrap-up, which calls calculate times methods from experiment, summarize experiment, plot experiment, and add experiment method from benchmark, so that eventually you can take a look below that at least in terms of JSON import, Polars look to be way slower than Pandas. So in this case, we have first point for Pandas. The second experiment evaluates on 10 repeats which library deals faster with reading CSV file to a data frame. And as per the plot below, it looks like Pandas, in this case, is way slower than Polars. So it takes around 60 seconds for Pandas to load 10 times the CSV, in which Polars means only 24 seconds. So in this case, the point goes for Polars. The next experiment covers simple mean aggregation, so I wanted to evaluate which library deals faster with aggregating some numerical value using mean function. And I repeated this experiment 50 times, and in this case, Polars is also better, which done that in 31 seconds, opposed to Pandas, which needed 16 points more. So the verdict is another point for Polars. The next experiment covers sampling 20% of the data, and in this case it was repeated 50 times. The whole experiment took less than 2 minutes, and it clearly shows Polars is once again better because it needed only 39 seconds to perform this operation 50 times, while for Pandas it was 54 seconds. So next point goes to Polars. Another use case, number 5, that is being evaluated by this benchmark is pivoting, so moving the data from rows to columns. I tested it here on 20 repeats, and here the verdict is also positive for Polars, which required around 28 seconds to do this 20 times, while for Pandas it was 35 seconds. So the verdict is similar as before, point for Polars. The next experiment is about melting. So in this case, I took 10,000 of repeats because melting is apparently quite fast in both libraries. And let's see the plot. And the plot tells us that Polars is still once again better and also substantially better because it required only 1.85 seconds to do this operation 10,000 times, while for Pandas it was way more because almost 22 seconds. So the verdict is very similar and point for Polars. The next experiment, number 7, covers iterating through 500,000 rows of a data frame. And let's see the results. And once again, similar to what we saw in the melt, the Polars library works way faster than Pandas, and it is way below, I think, even 1 second, correct? 0.38 seconds, while for Pandas it is around 23 seconds to iterate through 500,000 records from the data frame. So once again, point for Polars. Experiment number 8 covers joins, which is like very important thing in working with data frames. So let's see the results. And actually still Polars is faster than Pandas. So I performed 3 repeats, as you can see here. And the Polars library took around 33 seconds to perform these operations, while for Pandas it was about 18 seconds more. So the verdict is similar as in majority of experiments so far, point for Polars. Experiment number 9 is about using map or lambda function, or eventually, to put it in simple terms, to add a calculated field. So we want to use existing fields of data frame, apply some formula to come up with some calculated field. Let's see the results. Once again, Polars is way faster and way below 1 second. To do that, it's 0.55, while for Pandas is more than 1 minute. So the conclusion is similar, 1 point for Polars. The 10th use case we want to evaluate during the execution of this Colab is sorting. So let's see now the results, which library deals faster with sorting. And actually we can see the results are quite close. So yeah, this is like quite extensive operation in terms of execution time. And we can see from just one execution that Polars is better, but only slightly better. So it's 46 seconds compared to 48. So it's also a point for Polars, but actually it should be almost close to a draw. Experiment number 11 covers filtering using complex conditions, so we want to repeat 100 times filtering via more than one column and see what is the time. Let's do that. And similarly to majority of previous experiments, Polars is faster, so it took for Polars 27 seconds, while for Pandas it was 40.47, so the conclusion holds, 1 more point for Polars. For experiment number 12, we will do the opposite of what we did in the beginning. In the beginning, we created a CSV file and loaded it into data frame, and right now we will do the reverse operation. So we will dump a data frame back to a CSV. And if we take a look at the results, Polars is significantly faster here. So while the whole code cell took around 37.6 seconds, for Polars it was only below 2 seconds and the rest was Pandas. So here a big plus for Polars. Next use case I came up with is repeating 10 times, building a dictionary which holds in keys the column names and in the values list of unique values, so that it's like a nice tool for doing some EDAs. And if we take a look at the bar plot, we can see Polars is faster. There is not a big but significant difference, in which Polars was around half a minute to do so, and Polars was like 50% slower in this case. So in terms of use case number 13, Polars is better. Let's now evaluate in experiment number 14 how both libraries deal with converting data types. So I'm repeating 1000 times conversion of a column to int16 and back to int64. Just some random example. And what we can see is that in terms of data type conversions, both libraries are quite similar, but it looks like Polars is a bit faster, namely 51 seconds compared to 56. So here, once again, point for Polars. The next experiment covers how to copy a data frame and how long it takes. So what is interesting here is that for 100 repeats, I cannot see any bar for Polars. And I double check that, and eventually what happens here is that the time of execution is so small that the values that are then rounded to two decimal places return 0.00. So it's like very little amount of time, like iWing, that Polars needed to copy a data frame 100 times, while for Pandas it was 34.22 seconds, so in this case a strong 1 point for Polars. Experiment number 16 is about concatenating Pandas and Polars data frames. So what you can expect from this experiment is to get a data frame and concat 1 million records to it. And once again, the situation is very similar to the previous experiment, so Polars was insanely fast to do that, while for pandas it took around 47 seconds. So once again, a very strong point for polars. The last experiment, number 17, is about dropping nulls, which is like very common use case in different aspects of working with data. So what this code cell does, it artificially creates null values in both pandas and polar versions of the data frame, and then applies some function that aims to remove these nulls from the data frame. So let's evaluate the results. And in this case, Polars wasn't that fast, so actually there is some bar here, which is like 1.87 seconds to get rid of all of the nulls that were introduced in this data frame, while for pandas it was around 1 minute. So also for this experiment, we can mark a very strong point for Polars. And here we go. So when we run all of these code cells, what also happens is we can run one big plot that contains like comparison for all of the experiments between polars and pandas. We can also see the score, which is like very impressive for polars because out of 17 aspects that were evaluated during this benchmark, polars was better in almost all of them. There was only JSON import, you can see here, in which polars bar was higher than pandas. In some cases, out of the 16 experiments, polars was better. You can see that there are some aspects in which there was like very close to a tie. So I just highlighted them now. But also you can see aspects in which polars was like about 1 second or even below or even closer to 0 seconds. So it was like an I-wing, while pandas required way more time to execute equivalent operations. So I hope this notebook was useful. Please let me know in the comments what do you think about it. I encourage you also to load this Colab from the GitHub. I am sharing it in the description of this YouTube movie, and feel free to play with it, tune the and repeats parameters for your code cells, play with different versions, and so on. So until then, enjoy this notebook and happy benchmarking.